while, it once again involves Avogadro's number, so we'll get to that eventually. But we do need to talk about a little bit about molar mass and how to calculate that. Okay, and so the first part here is kind of in the notes a little bit, so you can just kind of follow along a little bit, and we'll talk a little bit about molar mass. And if I'm not sure exactly how far we'll get, but we need to be able to do that, obviously. So the mass of 1 mole of a substance, or 6.02 times 10 to the 23 particles of that substance, is called its molar mass. The symbol for molar mass is big M. Okay, so it is big M, and it is measured in grams per mole. Okay, big M measured in grams per mole. That's what molar mass is. You will probably find the molar mass on your periodic table. Okay, so we'll use that to calculate the molar mass. To determine the molar mass of an element is the average mass of grams in 1 mole of atoms of that element. The atomic molar mass of an element can be found on the periodic table. And to determine the molar mass of a compound, you have to take into account all the parts of the compound. So all the atoms, okay? We're just going to get right to some examples. So you got these examples on here. So get your periodic tables out. If you don't have one, go get one over there on the top, okay? Find lithium for me. Lithium. Hurry up. Lithium. So what is the molar mass? Another term for molar mass, of course, is atomic mass, basically. Okay, it basically means the atom mass, basically. Oh, 6.94? Yeah, okay. I don't know why I thought 6.98 for some reason. Okay, 6.94. So this would be 6.94, and that is measured, guys, in grams per mole. What that means is, and we'll write here big M. Okay, big M. 6.94. What that means is the following, okay? If I took 6.94 grams of lithium and put them on a scale, so we have some lithium in the back room. If I cut off exactly 6.94 and I put it on the scale, I would be weighing 1 mole of lithium. Okay? And 1 mole of lithium would be a huge number of atoms. Okay? You would be, in fact, 6.02 times 10 to the 23 atoms in this case of lithium. Okay? But instead of saying 6.94 grams for every 6.02 times 10 to the 23 atoms, that's a lot of writing. So we just say 6.94 grams for every 1 mole of lithium that we have. Let me reverse it for you for a second. If I took okay, 6.02 times 10 to the 23. Is that number there? Yes? Okay, it's a huge number, I think, right? Did I get that right? 3, 6, 9, 12, 15, 18, yeah, 21. Okay, so that's that number there. If I count it out, okay, and this is your punishment if you're not going to do homework from now on, okay? You're going to count out lithium atoms for me. Don't make any plans for the next, well, rest of your life, yeah? Because it would take a long time to count the number because it's really big. Okay, listen. If you took 602 with 21 zeros, if you took this many lithium atoms and you decide, hey, I counted them all out, I put them on the scale would read 6.94 grams. Okay? That's what it means, basically. All right? What's the molar mass of carbon? Quickly, molar mass of carbon. Somebody. 12.01 grams per mole. Okay? And you'll notice there's a common theme here, yes? As you keep going on the numbers, the weights get larger, yes? Why? Because there's more protons and neutrons, right? So if I take a 1 mole of carbon, it's going to weigh more than a mole of lithium because carbon has each atom has 6 protons and 6 neutrons for a weight of 12. Yes. So a carbon atom weighs 12-ish, right? 12.01, but 12. But a lithium atom only weighs 7 because it's only got 3 protons and 4 neutrons, right? What's the molar mass of hydrogen gas? Oh, trick question here. Be careful. What is the molar mass of hydrogen gas? Careful. Yep. Close. No. Yes? So what's the molar mass? 2.02, yes? Grams per mole. Okay? Hydrogen, I have no brighter, clever friends. We can't forget that stuff, guys. H2N2O2F2Cl2, hydrogen gas, H2, okay? That means it's got 2 hydrogens, so the molar mass of that is 2.02 grams per mole, yes? Okay, good? Okay, moving on. What about methane, CH4? Okay, how am I going to figure that out? So, what you're going to have to do is you're going to have to add up the individual elements, guys. So, how many carbons do I have? How many carbons? 1, yes? 1 carbon, okay? So 1 carbon. I'm not going to do this for all of them, so just relax. You can write this down, though. 1 carbon. Carbon is 12.01, yes? How many hydrogens do I have in CH4? 4. So I'm going to take 4 times hydrogen's molar mass, which is 1.01 grams per mole. Okay? And I'm going to multiply that, and I'm going to add those up, basically. I got 1 carbon and 4 hydrogens. I'm going to add all that up, and I will get what? 16.05. Does that sound right? 16.05 grams per mole. Okay? Good. We are going to add each of the elements up. I have four hydrogens, so 4 times 1.01, and I have 1 carbon, so 12.01. What about the molar mass of water? Okay, well, we know water is, of course, H2O, yes? Make sure you have a formula there, of course, first, yeah? So molar mass of H2O. So we have what? 2 hydrogens, so 2 times 1.01 grams per mole, and I got 1 oxygen, yes? So 1 times 16 grams per mole. I'm going to add all that together, type it in on your calculator, exactly like you see here. If you got a fancy one, it spits out the answer for you. Should be 18.02 grams per mole. Okay, good? Okay. Now, let's ramp it up a little bit here. What's the molar mass of magnesium nitrate? So, very quickly, I want you to write down a formula. That's the first thing we need to do. Magnesium nitrate. Yep. Yeah. Magnesium nitrate. Okay. And this, guys, is the problem. If you cannot write out the formula for magnesium nitrate, or you mess it up, you will never get the right answers. It is impossible. Okay? There is no shortcuts here. You got to know what ionic compounds look like, or molecular compounds, and we'll find out pretty quickly because I got some practice questions at the bottom here, and we'll find out if you can do that or not. And if you get that wrong, like I said, it doesn't matter if you know how to add up molar mass or not. you're going to be adding up the wrong numbers, okay? And guess what? We're then going to take this and do something with it tomorrow, which gives you the wrong number. And then we're going to add on to that, and you're also going to get the wrong number, okay? So all the practice with ionic compounds, molecular compounds, writing out chemical equations, still practice. You need to be able to do that, yes? Magnesium is a 2+, nitrate is a 1-. You'll find that in the top left. You need to swap, drop, and reduce. So therefore, you will get MgNO3. The 2 comes over and down, brackets. The 1 comes over and down, don't need brackets. Okay? Good? That's what you need to have. Okay? Now you have to say to yourself, okay, how many magnesiums do I have? How many magnesiums are there? 1. Okay? So I'm going to put here, molar mass is 1 times 24.31 grams per mole. That's magnesium, by the way. Plus, okay? How many nitrogens do I have? 2 is the correct answer. 2 times 14.01 grams per mole. And how many oxygens do I have? This is like balancing chemical equations, guys. 6, I believe. Okay, and we'll add all that up. You guys following me here so far? Okay, 1 magnesium, 2 nitrogens, and 6 oxygens. So that is, oh, here, I can do it on here. Well, no, I can't, but I wish I could. Okay, so this is what I do when I type these in, guys. On this calculator here, I just go 24.31 because I only need one of those, okay? And I just type it in exactly like you see it there. I don't need actually brackets in this case because the calculator is smart enough to do the order of operation. So it will do the multiplication and add it together, okay? It is not smart enough to do division correctly all the time, though. That's why you need brackets yesterday around 6.02. 6 and 16, which is actually 96. And you should get 148.33 should be your answer here. And once again, don't forget to put grams per mole. Okay? Good? Yes? Okay? So there's 3 examples. Now listen, okay? Ultimately, do I want you to write all this stuff out? I don't know. Maybe for the first couple you could. And then after that, if you're feeling okay, you probably don't need to. But we do need to write out the formulas for sure, okay, which I don't know if I gave you or not. I forget now. Well, I gave you some formulas, but some are words. They're in words. You need to write out the formula. And we do need to have some answers here for tomorrow. So you need to do basically this part. These were the examples here, guys. This part right here, where it says determine the molar mass of the compounds, is due for tomorrow, yes? Okay? And we need to finish this up tomorrow as well here. So we got quite a bit of work to do tomorrow. Okay? Good? If you don't understand, you need to come for extra